Today's lesson deals with more angles and arcs on circles. In this first little problem, we're going to stick with our little formula that says the angle is half the arc. So I would definitely write that out to the side. Angle is half the arc. Angle is half the arc. That's always going to hold true whenever the vertex is on the circle. So when the vertex is on the circle. So to reiterate that, I'll read this theorem real quick. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. I think this is much easier. Angle's half the arc. So angle 1 right here, the vertex is on the circle. You can see that. And this angle 1 intercepts this portion of the arc. What two letters of the alphabet do we hit there? B and A. So it hits arc BA. So whatever that arc is, half of that arc is going to give me that angle measurement. Now angle 2 is a really large angle though. Angle 2 is going to intercept over here. So angle 2 goes from here all the way over to this area. So focus maybe on B. It goes from B to C all the way to A. And why do I put BCA? Why do I use 3 letters here? Because that's called a major arc. 3 letters for major arcs, 2 letters for minor arcs. So half of that arc will give me angle 2. We're now going to use those concepts on example 1. Example 1 says find the measure of angle 1. So let's locate it real quick. Angle 1's over here. And if you highlight the angle, it helps some people, you can focus on the arc that it's intercepting. And once again, the angle is half the arc. Angle is half the arc. And you know some of these pieces. Do we know the angle? No, it's just called 81. Or sorry, angle 1. But it's half of the arc's measurement, which we do know. Half of 132. Does anybody know half of 132? Good job. Angle 1 is 66 degrees. Nice. Now this other one wants us to find an arc. So I'll probably highlight it. It says arc E around to F to D. And C, do you have an angle that hits that arc? Do you know that angle? Yes, that angle that it hits is 110. That's right there. And once again, angle is half the arc. Do we know the angle? Yes. It's 110. It's 1/2 of the arc we're trying to find. So I'm just going to call X for simplicity. How do you get rid of the 1/2? You can multiply by 2. So multiply this value by 2, and you get that missing arc of EFD. Its measure is 220 degrees. Now this next theorem changes things up. We've been using that theorem. Angle is half the arc. And that is when the vertex is where? When it's on the circle. So in the past we had angle is half the arc. So I'm going to write that real quick. Angle is half the arc. And once again, that was when it was on the circle. When it was on the circle. Now we have a different situation. We have this new formula. Angle is half arc plus arc. Arc plus arc. We're going to be adding 2 arcs. And the vertex, where's the vertex this time? It's not on the center, it's just inside somewhere. So it's inside the circle. It's inside the circle. So let's look at this. To find angle 1, I like to highlight it. And then I focus on this angle hitting the arc. What arc did I just hit? DC. Well, what we've learned, though, is we have things called vertical angles. And this one is vertical to over here, And this arc hits, sorry, that angle hits this arc. What's it called? AB. So these are all kind of in a row, if you can look at it like that. Those arcs and angles all have relationships to each other. Similarly, you can do that same process for the 2. So I'll erase these real quick. Here's our angle 2. Here's the arc that it hits. It hits arc BC. What else do you need to check? The vertical angle. So the vertical is right here, and it goes up and hits this arc, AD. The last thing you need to remember to help yourself out is how are angles 1 and 2 related to each other? They're supplementary. Good job. Angle 1 plus angle 2, in this case, are supplementary. They're a linear pair. Therefore, they are supplementary, so they add to 180. Sometimes, it's going to ask you to find this arc, but give you this angle. So what you'd have to do is subtract from 180, and then work towards finding that missing arc. Things like that. So using a lot of past knowledge will help you out. Here's the last little theorem that you've got to be able to be aware of. And focus on the vertex of the angle. Where's the vertex of these angles? Outside the circle. So write that down. Whenever the vertex is outside the circle, here's our new formula. Angle is 1/2 arc minus arc. Now some people even write this in. Big arc minus small arc. But truthfully, you're probably good logically with that. You can probably figure that out on your own. So no matter on any of these cases, that vertex is outside of the circle. And here's what you need to focus on. Whenever the vertex is here, here's my angle. It hits the arc AC and arc BC. Which one's the bigger one? So it goes first. BC minus AC. Here's the next one. Now this one is the one that tricks a lot of people for some reason. It hits 2 separate arcs. Here's one, and here's the other one all the way around. Which one's the big one? PQR. Here's the smaller one, PR. So we have a major and a minor arc. Here's the last one. We have our 2 arcs. XY minus YZ, big minus small. The other thing to notice about this example up here, and this is relating to some quiz and test questions, if I add these 2 arcs together, what do I get? 360. So this is actually using the whole circle. So keep that in mind. If you're just given one of these measurements of these arcs, you can find the other one. So if you're given that this is 100, how big is this other one going to be? 260. You can figure that out because you understand that a circle is going to add up to 360 degrees. All right, now we're going to try a couple more examples. Example 2 says, find the value of x. X is this angle in here. Is that a central angle? No, because it doesn't have a little dot in the middle calling it center. So this is not a central angle, so that means I should be looking for that formula that's just the vertex is inside the circle somewhere. So that's angle is 1/2 arc plus arc. That's the formula we're going to be using. Here's the angle. Do we know it? Nope. All right, so that's x. It goes in for the angle. I bring down my equals. I bring down 1/2. Now I'm going to be plugging in my arc values that angle hits. So this angle hits down here. It hits the 140, and its vertical hits the 112. Those are my 2 angles, 140 and 112. 140 plus 112. Good job, 252. Does anybody know half of 252? Yeah, 126. Done. So some key comments real quick. we use this formula whenever the vertex is on the circle. In the past, we used Plano angle as half the arc whenever the vertex was where? Sorry, I meant in this old simple one was when the vertex was on the circle. Up next, we have example 3. Where is the vertex on this angle? Outside. Whenever it's outside the circle, what formula do you use? Yeah, we're going to be subtracting the arcs on this problem. Arc minus arc. So remember, it's usually big minus small. Do we know the big and the small? Yeah, it tells you. 170 and 72. Those are my two arcs that I'm going to take half of. Half of 170 minus 72. What's 170 minus 72? Yeah, good math. Half of 98. Yeah, 49. That angle that we're missing, that x, is 49 degrees. All right, here are the last few problems we're going to be doing. These are some checkpoint problems. So on these, you got to determine where are the vertices of each of these angles. So this one is right there. It is on the circle. So you might want to write the word on the circle somewhere. This one is where? Inside the circle somewhere, not exactly middle. This one is outside of the circle somewhere. Because now these tell us our formulas. Whenever it's on the circle, its angle is half the arc. Well, here's the arc I'm trying to find. A, C, B. This angle is half of that arc. Well, I think we can do the math fairly quick. But anyways, 120 equals half of the arc. Multiply by 2, and you get the arc ACB is how big? 240. So this is all the work I want you to be showing right here. If you show me the setup of that one, I'm happy. I know you're understanding things correctly. Now, whenever it's inside the arc, we have angle is 1/2 arc plus arc. Arc plus arc whenever it's inside. And it kind of looks like a plus sign. If you look at it carefully, take your time, it doesn't look like a minus sign. So please be careful with that. Now, please be careful also with this 52. It's pointing over to here. That angle right there is the 52. But does the 52 line up with this arc and that arc? No, they don't line up. The 52 is over here. I want the angle that's right beside it. How do I find the angle that's right beside it? Okay, so if I do out to the side, 180 minus 52, what do I get? 128. So this angle right here is 128. That's the angle that I need for my problem. The angle that lines up with these arcs is 128. It's half of those arcs added together. Do I know the values of both of them? No, but that's okay. One is x, and the other is 144. This is simple algebra now. You can do one of two things. You can distribute the 1/2, or you can go ahead and multiply by 2. I think multiplying by 2 is a little bit quicker. What's 2 times 128? 256, good. So I got rid of the 1/2 by multiplying each side by 2. And now this is a very simple problem. Subtract 144, and what do we get? 112. Here's the last one. It's outside of the circle. So angle is half. What do we do with the arcs this time? We subtract those arcs. And we typically do big minus small to make our signs work out properly. The angle is given, it's 26. Do we know the big arc? No, it's y. And the small arc that it hits is 30. Once again, fast way to get rid of the 1/2 is multiply each side by 2. So I get 52 equals y minus 30. add 30 to each side, and we get y is 82 degrees. And logically, think through it. Does that seem feasible? If that's 30, that's 80? Yeah, it seems feasible. Now this last one mimics that example 4. To actually be able to do those problems, you would have to solve these triangles. So we're not going to work on solving right now. I'd rather you focus on 1, 2, and 3 for the moment. But you actually have to solve these triangles to figure out this angle, and then double it to get that angle, and then work through it from there. But we're not going to do that right now.